Welcome back to GordMaths. I hope you enjoyed our previous lesson on probability. In today's lesson, we will look at the addition and multiplication laws of probability. Remember to subscribe to this channel for more lessons. In our previous lesson, we discussed some terms such as the sample space, event, and experiment. Let's take a sample space U equal to 1, 2, 3, 4, 5, 6. This is a sample space for the throw of a die. Assuming there are two events, A, 2, 4, 6, which are the even numbers from the sample space, and B is the multiples of 3 from the sample space, then it will be observed that there is an intersection, A intersection B, which is 6. Now, if we represent this in a Venn diagram, we are going to get this. This is set A, this is set B. A is 2, 4, 6, and B is 3, 6. Where 6 is the intersection of A and B. And all these are from the sample space U. Now, A union B, which is also referred to as A or B, would be the whole set, which is 2, 3, 4, 6. Now, in finding the probability of A union B, we will say that the probability of A union B is the probability of A, which is this set, plus the probability of B, which is also this set, minus the probability of A intersection B. Now we are subtracting A intersection B because within this one we have 6. Within this one we have 6 again. So the 6 is repeated. Therefore we subtract it to avoid double counting. This is called the addition law of probability. Now there are also some events that do not intersect. We call them disjoint sets. For example, from this sample space, if we have the event P is equal to 3, 6, and the event Q is equal to 5, then P intersection Q is equal to an empty set. So there is no intersection for this. In that case, the probability of P union Q is going to be equal to the probability of P plus the probability of Q minus 0 because there is no intersection. And sets that do not intersect are said to be mutually exclusive. And so this is the addition law for mutually exclusive events. And then the first one is for intersecting events. Let's look at the application of this law of probability in some examples. Given the probability that x will not occur, which is the complement of x, 2 over 3, probability that y will occur is 1 over 2. And we are given the probability that x and y will occur, which is the intersection of x and y. We are going to find the probability of x or y occurring, which is the probability of x union y. So, from the addition law of probability, we know that the probability of x union y is equal to the probability of x plus the probability of y minus the probability of x intersection y, since these are intersecting events. Then, from the question, probability of x will be equal to 1 minus 2 over 3, which will give us 1 over 3. This is from the complement, the probability that an event will not occur. Then, probability of y is given as 1 over 2. Probability of x intersection y is also 1 over 6. So, the probability of x union y will be equal to probability of x is 1 over 3 plus probability of y is 1 over 2 minus 1 over 6. So we can compute this fraction as 1 over 3 plus 1 over 2 minus 1 over 6. The LCM is 6. This will give us 2 plus 3 minus 1. And that will give us 4 over 6, which is 2 over 3. That is the probability of x union y. Now let's take the second example. We are given the following data. We are given probability of x union A union B as 0.7, which will give us 7 over 10 in fraction form. We are given probability of A as 1 over 3 times the probability of B, which implies that 3 times probability of A is equal to probability of B from this data. Then we want to find the probability of A. Using the addition law, we will say that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. But we are told in this question that A and B are mutually exclusive, which means that they have no intersection. And so we will have probability of A is given in the question as, okay, we want to find probability of A. Then probability of B is 3 times probability of A minus 0, because the events are mutually exclusive. And this is given as 7 over 10. So we will have 7 over 10 to be equal to 4 times probability of A. Then 7 will be equal to 10 times this will be 40 probability of A. Then we divide through by 40 to have probability of A is equal to 7 over 40. Let's take another example on this. In a survey of 500 people, 75 said they had never married or given birth. 345 had married and 245 had given birth. A person is randomly selected. Find the probability that the person is married and had given birth. This is what we are finding. The probability that the person is married and giving birth. That is what we want to find. Then our sample space is the total number of people, which is equal to 500. So the probability that a selected person is married, number of married people, 345 over the sample space, and that is 0.69. Then the probability that a person had given birth, number of people who had given birth is 245 over this, and that is also equal to 0.49. Then we are given the number of people who said they had never married or given birth. Never married or given birth. This is married or giving birth. So the complement is never married or giving birth. That is 75 over the sample space, 0.15. So the addition law states that M union B, that is married or giving birth, probability of M plus probability of B minus M intersection B. Now from the data we have this, and this is what we are supposed to find. We can also say that probability of M union B is equal to 1 minus the complement, and that will give us 1 minus 0.15, 0.85. Then we will have 0.85, which is this, is equal to married is 69, 0.49 minus the probability of M intersection B. We want to find this one, so let's move this to the left hand side, and that will give us probability of M intersection B becomes positive 0.69 plus 0.49. Then we send this to the other side to become minus 0.85, and this will give us 0.33. Next, we will look at the multiplicative law of probability. Given two events A and B, such that the occurrence of A does not depend on that of B, or the occurrence of B does not depend on that of A, then we say that the events A and B are independent events. Then if we are given two independent events, the probability that both events A and B, which are independent, will occur at the same time, which is also giving us A intersection B, is equal to the probability of A times the probability of B. This is called the multiplicative law of probability. The probability that two independent events will occur at the same time is the probability that A will occur times the probability that B will occur. We will use more examples to explain this law. A company sells two machines P and Q, which operate independently. The probability that P will last for 10 years is 4/5, and the probability that Q will last for 10 years is 3/4. Find the probability that both P and Q will last for 10 years. Now, the machines operate independently. So we will say that this is the probability of two independent events. Then we are given that the probability of P lasting more than 10 years is 4/5, and the probability of Q is 3/4. Since they operate independently, the probability that both P and Q will last 10 years, which is P intersection Q, is equal to 4/5 times 3/4. That will give us 3/5. 4 cancels 4. So this is the first one. Then let's go to the second question. II says we should find the probability that only P will last for 10 years. And this means that Q will not last for 10 years. There are two machines. So the probability that Q will not last for 10 years, which is the complement of Q, is 1 minus the probability that Q will last for 10 years. And this is 1/4. So probability that only P will last for 10 years means P will last for 10 years and Q will not last for 10 years. And that is the probability of P times the probability of Q complement. So we will have probability of P is 4/5, and that of the complement of Q is 1/4. And this should give us 1/5. 4 cancels 4. Now the third question. The probability that only one machine will last for 10 years. So it is either P will last for 10 years and Q will not last for 10 years. Or P will not last for 10 years and Q will last for 10 years. And this is probability of P times probability of Q complement plus the probability of P complement times the probability of Q. Or is plus in probability. Then the probability of P complement is 1 minus the probability of P is 4/5, which will give us 1/5. So our resulting probability will be probability of P is 4/5 times that of Q complement is 1/4. Then plus the probability of P complement is 1/5 times the probability of Q is 3/4. And this will give us 4/20 plus 3 over 20, which is equal to 7 over 20. We will take more likely examination questions in our next lesson. See you then.